Okay, so this is 8.6, identifying special quadrilaterals. So we're going to take all of our knowledge of all of Unit 8 and kind of condense it into this section and kind of make sure that we understand all these different figures. So what I want for you to do first is I want for you to pause me and I want you to fill out this table. So what you're doing is you are going to, like in this column, a parallelogram, all sides are congruent. Well, on a parallelogram, it doesn't have to, by definition, have all sides congruent. So I'm not going to mark that as an X. Both pairs of opposite sides are congruent. That is true. On a parallelogram, both pairs of opposite sides do have to be congruent. So that is by definition part of a parallelogram. Now, on a rhombus, all sides are congruent. That by definition has to be true of a rhombus. Now, a rhombus is a subcategory of a parallelogram. So rhombi have to have all sides congruent. Parallelograms don't have to, so I'm not going to mark it. So go through and fill out this entire table. So pause me, unpause me when you are done. I'm going to talk through it now. Both pairs of opposite sides are congruent, yes. Both pairs of opposite sides are parallel, yes. Both pairs of opposite angles are congruent, that is true. Exactly one pair of opposite sides are parallel, so no, that actually only happens with a trapezoid, so I'm going to go ahead and mark that. All angles are congruent, no, that only happens with a rectangle and square. Exactly one pair of opposite angles are congruent, only one pair. That again is only a kite. Oops, only a kite. Diagonals are perpendicular, not on a parallelogram, they don't have to be. Not on a rectangle. On a rhombus they will be, and on a square they will be. And a kite they will be. Diagonals are congruent. Parallelograms, diagonals don't have to be. Rectangles do. Rhombi no. Square, yes. Kite, no. Trapezoid, no. Diagonals bisect each other, yes on a parallelogram, so yes on a rectangle, so yes on a rhombus, so yes on a square, no on a kite. One of your diagonals is actually bisect, but not both. And trapezoid, no. Consecutive angles are supplementary, yes on parallelogram, yes on rhombus, and rectangle, yes on square, no on kite. And a trapezoid is, yeah, well, kind of. So like these two will be supplementary, but these two aren't, and these two are still consecutive, so I'm not going to mark that. So I went through and did from here down all the way across, so I'm going to come back. Exactly one pair of opposite sides are parallel, that's only a trapezoid. Both pairs of opposite angles are congruent, so rectangle and a rhombus and a square, not a kite, not a trapezoid. Both pairs of opposite sides are parallel, yes, 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 no, and no. Both pairs of opposite sides are congruent. So yes, 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 no, and no. All sides are congruent. That is only a rhombus and a square. Hopefully I didn't miss any. It's easy to miss one on there. Okay, give the most specific name for this quadrilateral. So this is a trapezoid, by definition, one pair of parallel sides, but my base angles are equal, which would make these two legs equal. So that means that this is actually an isosceles trapezoid. So that is the most specific name. All congruent sides, so it's a rhombus. More specific, it's a rhombus or a square, but then I have 90-degree angles, so this would be a square. This one, opposite one set of angles are congruent. These adjacent sides are congruent, and these adjacent sides are congruent, so this is a kite. The only more specific kite that I could have would be a right kite, but I have no right angles that they're showing me for sure here. Now this one looks like a rectangle, right? But they're not showing us any angle measures, and they're just telling me that this is parallel to this and this is parallel to this. So this, by definition, it can only be a parallelogram. That is the most specific name because we don't know any other things going on there. Tell whether enough information is given in the diagram to classify the quadrilateral by the indicated name. So could I say that this is a rectangle? So we know opposite sides are parallel, and we know those opposite sides are parallel. We also know that the diagonals bisect each other. Well, they only bisect each other. If I go back up here, diagonals bisect each other. So they bisect each other on all those. So no, I don't have enough information. I could say that this is a parallelogram. Oh, but they bisect and they're congruent to one another. So this would be either a rectangle or a square, and a square is a subset of a rectangle. So I could say actually yes on this, because they bisect each other, but they're all four pieces are equal. That only happens on a rectangle and square. This one, isosceles trapezoid, these two add to 180. This is congruent to this, and base angles are congruent and parallel, so this one's a yes. A rhombus, I know 3 sides are congruent. I know the base angles are congruent, but those sides are congruent. But I don't know this side is congruent to this, so this could actually be a trapezoid by definition. So no, I cannot say it's a rhombus. This one's a kite. I know those two are congruent, but I don't know that this is congruent to this, and I don't know anything about their angle measures, so no, I cannot say that that's a kite, because these two would have to be congruent to one another also. All right, last page of notes for this unit. Okay, points A, B, C, and D are vertices of a quadrilateral. Give them a specific name for A, B, C, and D, and justify your answer. So 2, 2 is A. 4, 1, 2, 3, 4, 5, 6 is B. 2, 4, 6, 1, 2, 3, 4, 5 is C. 1, 2, 3, 4, 1 is D. So this one looks like it is a rectangle. The easiest way to prove that it is a rectangle is to prove its lengths or opposite lengths are equal and that they are parallel. Well, actually, the easiest way to prove that this is a rectangle would be that I have 90-degree angles and that I have parallel sides. So AB, its slope is rise 1, 2, 3, 4 over 2. So 4 over 2, which is equal to 2. CD, it's a rise 1, 2, 3, 4 and a run of 2. So that is a slope of 2. A to D is a rise of 1, go back 2. So that is a negative 1/2. And BC is also a negative 1/2. So this is parallel to this, and this is parallel to this. So we know that it's at least a parallelogram. Now to prove that it's a rectangle, I would need to prove that this is 90 degrees. And so if it's 90 degrees, those slopes have to be opposite reciprocals, right? So the opposite and a reciprocal of 2 is a negative 1/2. So this would be yes, it is a rectangle. Okay. If I would need to prove that then it was a square for some reason, let's say it looked like a square, then I would also have to prove that all side lengths are equal. Okay, last one of these graphing, 1, 2, 3, 4, 5, up 1, 0, negative 6, 2, 3, 4, 5, 6, and 5, 1, 2, 3, 4, 5, 1, 0, 3, 1, 2, 3, D. Let's see what this looks like. Oh, that kind of looks like a kite, right? This kind of looks congruent to this. This looks congruent to this. And those angles look like they're congruent. So to prove that it's a kite, I'm going to find the lengths of each of these. So remember, distance or length is x2 minus x1 squared plus y2 minus y1 squared. So to find A to D, so here are my two numbers that I'm going to use. I'm going to do x2, 0 minus a negative 5, so that's 5 squared is 25. Plus 3 minus 1 is 2, 2 squared is 4. So A to D is square root of 29. I need to prove that C to D is the same length. So here's C and D, so 0 minus 5 is negative 5, negative 5 squared is 25. 3 minus 1 is 2, 2 squared is 4, so that is square root of 29 also. So those two are the same length. Now I need to prove that A to B is congruent to B to C. So same way here. A and B, 0 minus negative 5 is 5, squared is 25. Negative 6 minus 1 is negative 7 squared is plus 49. So that is square root of 74. And then B to C, these two, 5 minus 0 is 5, 5 squared is 25. 1 minus a negative 6 is positive 7 squared is plus 49, so that looks like it's going to be the same. So those are equal and those are equal to make this a kite. Okay, last two. In exercises 11 and 12, which two segments or angles must be congruent so that you can prove the indicated quadrilateral is the indicated quadrilateral? There may be more than one right answer. So I would also have to prove, since this is equal to this, I would have to prove that this angle is equal to this. Or you could prove that this is equal to this. So you would need one of those two things. Isosceles trapezoid, I would have to, so we know that this is a trapezoid. I would either have to know that this side's equal to this, or this base angle is equal to this base angle. Or I think you can do this by knowing that this piece of the diagonal is congruent to this piece and this piece is congruent to this piece, as long as those pieces are congruent. But I would stay with the angles down here and then the side lines being congruent. And that is the last section of Unit 8. Yay for you guys. Okay, so 2 homework assignments. You're going to have a Schoology 8.6, and then you're going to have pages 11 and 12 in your packet that you will need to complete. All right. Oh, and then put the answers into Schoology. Thanks, guys.